Hey guys, welcome to 3.1 Extrema on an interval part 2. So in this lesson, I told you guys in the last video that we're going to be using derivatives to find our absolute minimum and absolute maximum. In the last video, we haven't gotten there yet, but in this video we will. So in the last video, I left you guys off with a question. I asked you guys, what conditions are necessary to guarantee that there will be a maximum and a minimum? Well, the answer to the question lies in the previous example. So letter A, we had a maximum and a minimum to be defined. These 2 points were defined. Well, why were they defined? Well, they were defined because we had the minimum right here and the maximum here. And what do you notice about those 2 points? They were defined. They weren't holes. Letter B, we had a hole here, which means that the maximum could not be defined. And letter C, we had a hole at the lowest point, which means the minimum could not be defined. So that again, what conditions are necessary to guarantee that there will be a maximum and a minimum? Well, the conditions are continuity on a closed interval, which means I have a graph in between A to B, and A to B are defined, so there must be some sort of maximum and some sort of minimum. There has to be. And on the next page, we're going to go ahead and talk about a theorem that says that. Extreme value theorem, known as the EVT. If f is continuous on a closed interval A to B, then f attains an absolute max and an absolute min for some numbers C and D in A to B. So let me go ahead and just draw a picture of this theorem. So it says here, if f is continuous from A to B, so I'm gonna say that that's my A, that's my B, and the next part says then f attains. Notice that it says f attains. It didn't say that it might attain or it could attain. It says that there will be a maximum and a minimum value. So let me go ahead and draw a picture. So I'm going to say that this is my point for A and that's my point for B. So I'm going to say that that's f of A and that's f of B. Now, how does a continuous function look like? A continuous function looks like a function with no holes, no gaps, no discontinuities. Now, just by looking at this function here, do I have an absolute minimum? Yes, I do. My absolute minimum is this little green dot here, and that's going to be my C, or I'm sorry, I'll let that be my D. Do I have an absolute maximum? Yes, I do. It's way up here, and that is my C. So that means that my f of C is my highest point, and my f of D is my lowest point. So that's one way you could represent the extreme value theorem. You can just draw a picture and just see it's true. Okay, so let's go ahead and look at the next steps. Here are the guidelines for finding extrema on a closed interval, also known as the candidate's test. To find the extrema of a continuous function f on a closed interval A to B, we use the following steps. Step 1, find f prime and the critical numbers of f in A to B. Step 2, evaluate f at each critical number. Okay, so let's go back to step 1. It says here, step 1, find the critical numbers. Now, why are critical numbers so important? Let's go back to the definition of critical numbers. So I had told you guys to put a star next to it. It says here, if f prime of C, if the derivative of C is equal to 0 or not differentiable, then C is called a critical number. So why is critical number so important for finding absolute max, absolute min? Let me draw you guys a picture. Okay, so we know that this graph has an absolute max. I'm going to say the absolute maximum is right here. Now, what is the slope of the function before the absolute maximum. For example, what is the slope here, positive or negative? And you guys would tell me it's positive. What about after the absolute maximum? Negative. But what is the slope at the absolute maximum? Well, the slope is a flat line like that, and we say that that slope has a slope of 0. And we know that slope means the derivative. So at some c, my derivative is equal to 0, which means if I can find my critical numbers, then I could potentially find my maximum and my minimum values. So let's go ahead and read the next steps. Step 2 says evaluate f at each critical number. Evaluate f at each endpoint. So we're also going to use the endpoints, because if you notice in the previous example before, in the last video, we noticed that my endpoint here was my highest point. So we're also going to determine if endpoints could also provide us a absolute maximum or absolute minimum. And the last one says whichever is the least is the minimum values, and whichever is the greatest is the maximum value. So let's go ahead and do our first example. Find the absolute maximums and minimums of f given on the given closed interval, and state where these values occur. So example letter A. So we want to find the absolute maximum and absolute minimum. Okay, so we're going to go ahead and test the endpoints, but not now. Let's test them last. We first need to find our critical numbers, and our critical numbers mean that we have to find where the derivative is 0 or undefined. So first, that means find the derivative. The derivative of this is 6x minus 24. And then I had to find my critical numbers, which means I had to set my derivative equal to 0. Oh, 6x, yes. Okay, 6x minus 24 equals to 0. And then I solve for my x. So what x could make this 0? Well, my x has to be 4. So that means that 4 is my critical number. So 4 could be either a maximum or a minimum. Okay? And we have to test it. So 4 is a critical number, so we have to test 4 and we have to test the endpoint. So we really have 3 candidates. And how do we test it? Well, look at step 4. We're going to plug these numbers into our original equation and see which one is the least and which one is the greatest. And we have to have an absolute max and absolute min, especially since we're on a closed interval from -1 to 5. So it's very simple. You just draw an x and y table, and then we're going to go ahead and check -1, 4, and 5. If we plug in -1 into the f of x, then it's 3 times -1 squared minus 24 times -1 minus 1, and that is 3 plus 24 minus 1, which is 26. Number for x equals 4. Let's see if that one is our maximum or minimum, or we have to do them all first. So let's go ahead and see what that is. 4 squared minus 24 times 4 minus 1, and that is 4 squared is 16 times 3 is 48. 24 times 4 is 96. Take away 1. Well, I know that these two subtracted is -48 minus 1, -49. Now let's try the last one. 5. 5 squared minus 24 times 5 minus 1. 5 squared is 25 times 3 is 75 minus 24 times 5, which is 120 minus 1. So let me go ahead and just subtract these two numbers. So -120 plus 75 will give me -45 minus 1, which is a -46. Okay, so which one is my lowest? My lowest is -49, and x equals 4 is the x value that gives me my lowest, and my highest is the only positive number here in this table. So f has a maximum at -1 comma 26, and well, I should say here absolute max at -126, and absolute minimum at, what is this, 4 comma -49. So there you go. That is how you figure out your maximum and your minimums using your derivative. So I'm going to go ahead and finish off the rest of the examples in another video. See you guys then.